In January 2026, nearly 4 years after the event itself, Russian government officials formally acknowledged that Ukrainian missiles had sunk the Moskva. The Moskva, the guided missile cruiser that served as the flagship of Russia's Black Sea Fleet, the largest Russian warship sunk in combat since the Second World War, lost in April 2022 when Ukrainian-built Neptune anti-ship missiles ignited its ammunition magazines, was only admitted to have been sunk by Ukraine in January 2026. For nearly 4 years, the Russian state had maintained that the loss was caused by an onboard fire and ammunition explosion, a technical malfunction, and an accident. The acknowledgement, when it finally came, was a quiet one. There was no national moment of reckoning. There was no ceremony for the sailors who went down with the ship. There was no accounting for the failure of the air defense systems that were supposed to protect it, some of which were documented as out of commission at the time of the strike. The Moskva simply joined the official record of what Ukraine, a country with no functioning navy, had done to the Russian Black Sea Fleet, a record that, by early 2026, included the destruction or serious damage of approximately 1/3 of the entire fleet, without Ukraine firing a single weapon from a warship of its own. The opening fact of this story is the one that renders every subsequent detail of the campaign almost paradoxical. When Russia's full-scale invasion began on February 24th, 2022, Ukraine possessed exactly one warship, a single Soviet-era frigate. It was scuttled by Ukrainian forces in the port of Mykolaiv to prevent its capture, rather than allow Russia to add it to the fleet that was already blockading Ukraine's coastline, firing ballistic missiles at Ukrainian cities, and preparing to launch what analysts widely expected to be a devastating amphibious assault on Odessa. Russia's Black Sea Fleet at the same moment counted 74 vessels, surface combatants, submarines, amphibious assault ships, missile carriers, support vessels, and the Moskva at their center. A cruiser that had deployed from ranges exceeding 60 miles offshore specifically because its designers had built it to be untouchable. The asymmetry between the forces facing each other in the Black Sea in February 2022 was so extreme that military analysts did not spend significant time analyzing the naval dimension of the war. There was no naval contest to analyze. There was a Russian fleet, and there was nothing. What Ukraine built in place of a navy, and what that construction has produced across 4 years of systematic campaign, is the most significant rewriting of naval warfare doctrine since the introduction of aircraft fundamentally altered the primacy of battleships in the Second World War. Ukraine developed, fielded, and scaled the CE, baby unmanned surface vehicle, a remotely controlled explosive drone designed to travel at high speed across open water and detonate against the hull of a warship. The Sea Baby uses a low profile that makes radar detection difficult, is steered by operators using a video link transmitted through satellite communications, and carries a warhead sufficient to cause catastrophic hull damage to large surface combatants. It costs a fraction of a percent of what the ships it destroys cost to build. Ukraine crowdfunded its initial Sea Baby development and production through the United 24 platform, the same presidential fundraising tool used for drone purchases, with a campaign that explicitly told donors that $25 million would produce 100 sea drones at approximately $250,000 each. The campaign succeeded, the drones were built, and the Russian Black Sea Fleet began encountering them in waters it had believed were under its control. The Moskva had set the operational template in April 2022 by demonstrating that shore-based anti-ship missiles, specifically the Neptune, a Ukrainian-developed subsonic cruise missile designed with help from Soviet engineering documents, could destroy a flagship cruiser that was operating 60 miles from the coast. The Neptune's effectiveness against the Moskva was not simply a function of its warhead. It was a function of the targeting solution Ukraine obtained by using a combination of its own radar operators, U.S. shared intelligence, and a Turkish-supplied Bayraktar TB2 drone that reportedly drew the Moskva's radar attention upward while the Neptune missiles approached from sea level, below the detection threshold of fire control systems, distracted by the drone overhead. The combination of multiple sensor inputs, a tactical deception creating a multi-axis engagement geometry, and missiles traveling below the radar horizon was not in any doctrine manual. It was improvised by operators who had studied the Moskva's known vulnerabilities and designed a strike around them. The cruiser sank on April 15, 2022, taking a still undisclosed number of sailors with it, and the Russian Navy has never formally accounted for those casualties. After the Moskva, the Russian surface fleet began what the British Ministry of Defense would eventually describe, in spring 2024, as a functionally inactive posture, pulling further from Ukrainian shores, avoiding exposure, seeking safety in distance rather than capability. Ukraine exploited that withdrawal by opening the Western Black Sea to its own grain shipments, allowing Ukrainian ports to resume exports that had been blockaded since the invasion's first week. But Russia's retreat did not protect it from what came next, because the Sea Baby could follow. The Kerch Bridge, the 12-kilometer span connecting occupied Crimea to mainland Russia, built personally on Putin's order and opened with ceremony in 2018, was struck by Ukrainian surface drones in July 2023 and damaged again in October 2023, each attack requiring repairs that took months and disrupted the logistical artery through which Russian forces in southern Ukraine received supplies. Individual fleet vessels were hunted at sea and in port. The Rostov-on-Don, a Kilo-class submarine capable of launching Kalibr cruise missiles at Ukrainian cities, was destroyed in September 2023 by Ukrainian missile attacks in the port of Sevastopol, the first confirmed destruction of a submarine in port by a precision strike in modern naval warfare. Another Kilo-class submarine was severely damaged by Sea Baby underwater drone attack at the port of Novorossiysk in December 2025, marking the first confirmed use of an underwater drone system to disable a submarine, a category of weapon use that had never before been recorded in any conflict. The Novorossiysk attack deserves particular attention because of what it revealed about the trajectory of Ukraine's maritime weapons development. The Sea Baby system, which had initially been designed as a surface-traveling explosive drone for attacking surface ships, had been evolved by December 2025 into an underwater variant capable of approaching a submarine in port below the waterline and detonating against its hull where the vessel's armor is thinnest and where hull integrity is most critical for maintaining submersion capability. Developing an underwater drone from a surface drone requires solving a fundamentally different engineering problem: pressure compensation, navigation without GPS at depth, propulsion efficiency in water rather than on its surface, and stealth against acoustic detection systems that port facilities use for exactly this threat. Ukraine's engineers accomplished all of this in a compressed wartime development timeline. The December 2025 attack on Novorossiysk confirmed not only that they had succeeded technically, but that the system was operationally deployable in the defended waters of a major Russian naval base, meaning no Russian port in the Black Sea theater offered reliable protection against it. The forced withdrawal of the Black Sea fleet from Sevastopol to Novorossiysk, the event that the British Defence Ministry characterized as the fleet becoming functionally inactive, is perhaps the most strategically consequential territorial concession Russia has made in the naval dimension of the conflict. And it was achieved without Ukraine recapturing a single square kilometer of occupied land. Sevastopol had housed the Black Sea fleet continuously since 1783. It was the harbor that Catherine the Great's commanders established, that the Tsars fortified, that the Soviet Union expanded into a major naval complex, and that Putin seized with Crimea in 2014 specifically to preserve Russian naval presence in the Black Sea, losing Sevastopol as an operational naval base, not to an amphibious assault, not to a land campaign, but to Ukrainian drones and missiles that made the harbor too dangerous to use for ships that could not be replaced, represents the emptying of precisely the strategic logic that justified the annexation of Crimea in the first place. The launch itself will fly a revised trajectory that differs from previous Starship flights in ways that reflect lessons learned from the challenges of Flights 10 and 11. The new trajectory takes the vehicle on a more southerly departure arc, over the Gulf of Mexico and Caribbean rather than the previous easterly path. The FAA approved the adjusted departure path specifically because it routes any potential debris fall zones over open ocean waters rather than populated or trafficked areas. The new window runs from 5:30 p.m. to approximately 7:43 p.m. Central Time, an afternoon window rather than the early morning windows used for several previous flights. Daily backup opportunities exist from May 12th through May 18th. If the first window is scrubbed, by weather, by a technical hold, by a sensor reading that the automated abort system cannot accept, SpaceX has 7 days of windows to work with before the advisory period closes. The mission profile for Flight 12 is deliberately more conservative than Flights 10 and 11, and this is the most strategically interesting decision SpaceX has made in planning this campaign. Flights 10 and first stop 11 successfully demonstrated booster catch operations. The Mechazilla mechanical arms at the launch tower grabbed the returning Super Heavy booster out of the air, a feat that still seems impossible to anyone who watches the footage. Flight 12 will not attempt a booster catch. Both the booster and the ship are targeted for splashdown rather than catch or landing. This is not a step backward in capability. It is a deliberate choice to reduce the number of variables in the first VQ-3 flight, to validate the new engine architecture, the new vehicle structure, the new pad systems, and the new trajectory, without simultaneously pressing for the catch milestone that Flights 10 and 11 already demonstrated. SpaceX is following the engineering principle of testing one new thing at a time. Flight 12 tests V3. Booster catches will return in subsequent V3 flights once the baseline vehicle performance is confirmed. The new launch pad, orbital launch. Pad 2 at Starbase is itself a significant milestone embedded in the Flight 12 story. Previous Starship flights all launched from orbital launch, Pad 1. Pad 2 was built from the ground up with lessons from Pad 1's experience. A redesigned flame trench, a water-cooled steel deck, a completely rebuilt tank farm, and integration points for the V3 vehicle's commodity connections. Flight 12 will be the first orbital launch attempt from Pad 2. The pad infrastructure was one of the contributors to the aborted 10-engine static fire. Ground support equipment issues rather than vehicle issues. Those ground support systems have since been diagnosed and addressed, but the first full launch from a new pad always carries additional uncertainty. Every interface between rocket and ground, every propellant loading sequence, every pressurization and conditioning procedure, all of it is being executed at full operational scale for the first time in pad history on May 12th. The regulatory picture is actually one of the cleanest aspects of the Flight 12 campaign, which represents a significant change from earlier Starship history. The FAA granted a launch license covering dates through October 2026. The FCC approved communications licensing for the mission. There is no regulatory bottleneck here. No environmental review pending, no mishap investigation from the previous flight requiring closure before the next one can proceed. Flight 11 ended with a successful mission. No debris incidents, no off-nominal vehicle behavior that would trigger a hold on subsequent flights. The regulatory path to May 12th is clear. Whether the vehicle is ready is the only question the FAA cannot answer for SpaceX. Can they make it happen? The honest analysis is this. The May 12th date is real. It is in the Cadena advisory system. It is in the FAA operations advisory. It is confirmed by SpaceX's preparation timeline at Starbase. The vehicle is stacked on Pad 2. The hardware has passed its most critical test, Ship 39's full-duration static fire. The trajectory is approved. The regulatory clearance is in place. The technical risks are known and being managed. The 33-engine booster test that cut short at T plus 1.88 seconds is the most significant open question. SpaceX will either conduct an additional static fire attempt before May 12th to validate the booster's full-duration performance, or it will proceed to launch with the data it has and trust the abort system to identify and respond to any anomaly in the first seconds of flight. The historical pattern in Starship development provides context but not certainty. Flight 4 slipped by months. Flight 8 came close to its advertised date. Flight 11 launched within a week of its first announced target. The program's relationship with its own timelines has improved progressively as the technical challenges shifted from novel and unpredictable to understood and manageable. V3 is novel again. The team is tackling new hardware with new infrastructure on a new pad. But they are doing it with 4 years of Starship campaign experience and a workforce that has processed 12 iterations of the most complex rocket program in history. The capability to hit an aggressive date exists. Whether every technical check between now and May 12th comes back clean is a question only the hardware can answer. What Flight 12 means for the future of space exploration, assuming it succeeds, is worth stating clearly. A successful V3 debut triples Starship's payload capacity. It validates the Raptor 3 engine architecture that will power every future Starship flight. It opens Pad 2 as a second operational launch site at Starbase, doubling SpaceX's launch rate potential for Starship missions. It puts NASA's HLS lunar landing timeline back on track. It demonstrates that SpaceX can iterate from V2 to V3 in a single development cycle. And it establishes the foundation for Ship 40 and beyond, the production standard starships that will eventually carry humans to the moon, and, if Elon Musk's timeline holds, to Mars. May 12, 2026, 5:30 p.m. Central Time. Orbital Launch Pad 2, Booster 19 and Ship 39, 33 Raptor 3 engines firing simultaneously. Now it uses 140 tons of thrust. The most powerful rocket ever built leaving the ground for the first time. Launch time, and the whole world is watching to find out if they can make it happen.